and it's much bigger of a crowd, I guess, from last year, which is good. And thank you for taking time to attend this gRPC conference. I think it means a lot. First, to see all of you here. Second, I think for us sharing how the exciting times with gRPC are going to be in the world of AI that we're going to live in. I'm just going to start with a brief overview of what the market has trended over the last 25 years. As we all know, we went from the internet era, where we built a lot of the capacity, a lot of workloads, a lot of e-commerce, a lot of new companies started showing up using the internet era. We went from internet to streaming with YouTube and the likes of Netflix, et cetera, with cloud coming to the making. And now we are at the fourth, which is, I think, the largest inflection point that we have seen for decades. And what does that really mean? It actually means the current offerings, the current capabilities we have in networking, in gRPC, have to evolve. They cannot be exactly the same that we've done for the last 2 decades. Almost rethinking or reimagining what the networking stack is going to look like. With training and inferencing, we will need to have a high performance, low latency, and a cloud infrastructure that can support all type of models, bring any type of agent, be able to connect securely to any model or tools. So let's talk more about what we see in the industry from an AI perspective. Just to give you a brief overview of what enterprises are seeing. One, there's about 93% of the Fortune 500 that are already using more than one model. On an average, we see each of these enterprises for different type of workloads using up to 3 models. And that creates complexity. That creates underutilization and lack of cost efficiency on the GPU, TPU infrastructure. We also see, while we see a lot of petabytes of data that's being transferred, being driven by training, there's a huge, huge focus from almost every enterprise that's trying to evolve their applications to become Gen AI applications that actually leverage inferencing as a much larger workload than we see from a training perspective. So whatever we build now from a networking perspective has to have that continuum with addressing the training needs of high performance, low latency, but continue that with the inferencing as that becomes much more dominant in the market. Now, we can't ignore security, as I've shared last time as well. One of the big things on cloud networking that we do, security has to be built in, has to be thought through in everything that we do. Cannot be an afterthought, cannot be a solution that we bring that is bolted on in the future. And with AI, I'm sure you guys have read news about new LLM models and how easy they were to break into. Completely removing the guardrails for an LLM model, being able to do poisoning of the model, being able to do data exfiltration, being able to ingest or inject malicious traffic to help make the LLM model hallucinate. And we've seen many reports that have come up. Here, like 90% of the prompt leaking data that I have was for a very specific model that was introduced back in January and February. Now, as enterprises, we absolutely want to make sure that your data is protected. It's secure, and the LLM model, the agents, as well as the tools that you do, and the intercommunication is as secure as possible. Now, with that, I want to first announce and talk about capabilities that we launched in the last couple of months. When I talk to customers and we talk about AI, there's 3 strategies that customers are building together. The first, obviously, being an AI and a cloud strategy. Where's my GPUs going to be? Am I going to use GPUs versus TPU? What models am I going to standardize on? What workloads am I going to prioritize and move into the cloud to leverage and evolve them to become Gen AI applications? The second biggest strategy is data management. Like petabytes of data have to be transferred closer to the GPU, TPU infrastructure. How do you transfer that in a secure, high performance, low latency manner? And the last thing that I always talk about, you need a robust evolution of your networking strategy. Networking is at the foundation to making sure that enterprises can now move and leverage the power of cloud, leverage the power of AI, leverage the power of the model infrastructure, the agents that they need to build in order to evolve their applications. So that's exactly what we did. We started the journey with data ingestion. We want to make it easier and simpler for customers to be able to move data into the cloud. And we were very pleased to announce 400 gig of Google Cloud Interconnect, where customers can now connect. It's 4x of what we had before. It gives a much better price point, and you can move in much more data much faster in a high-performance, low-latency manner. Fully reliable, fully SLA managed. So that interface that we're giving is backed by our reliability development. The second biggest capability is obviously be the ability to support GKE. As we know, Kubernetes and GKE is almost the de facto standard for any inferencing or Gen AI application that we are seeing. We now support up to 65,000 nodes with each GPU cluster. Not only that, we also developed an RDMA VPC that can do 3.2 terabits per second for GPU to GPU communication or TPU to TPU communication in a low latency, high performance, non-blocking manner. That was super, super critical for us to do. Last, we also realized that the Gen AI, the AI ML applications, both training and inferencing, are very different than how we were supporting web-based applications. Their traffic patterns are different. Their needs are very different. You have to look at KV caching and other metrics that come in order to be able to do intelligent traffic management. And that's where we introduced the inference gateway. Now let me talk to you more about the inference gateway, because this one is super, super exciting for us. We are obviously first in cloud to be able to offer an inference gateway that is natively integrated into our GKE architecture. It improves inference performance by offering 60% lower latency. It offers 40% higher throughput. And the reason we are able to do this is because we have intelligence from KV cache from the GPU models, be able to optimize that traffic management and get optimal experience. We also work with any type of model, whether it be VLLMs, the NVIDIAs, the Jetstreams, and others. And all of this needs to be made available through a gRPC infrastructure as well. And that's where it's extremely, extremely important. Now, as we go into the second pillar, as we all know, cost of GPU, TPU is extremely high. Is there anything that networking can do by being able to support and lower down the total cost of ownership? And one of the challenges that we took on as a team is the ability for us to now provide intelligent traffic management based on the GPU utilization of the model or multiple models on that infrastructure. And we believe we can lower your total cost of ownership by about 30%. And this is not just networking cost, this is the overall bill of material, where predominant cost is of the GPU and TPU or the AI infrastructure that you're investing in. Last, I talked about security, and that's extremely important for us. We have seen attacks like prompt injection attacks, training data poisoning, model stealing, sensitive data exfiltration. And with Inference Gateway, we have now integrated, providing you the best of breed security appliances that you want to bring in. Could be an ISV vendor of choice, could be the PanW AI firewall that they have, could be any other vendor, could be our own native model armor that you could use. Giving you that flexibility so that your security controls, your SecOps, your security teams are completely confident about moving those workloads into the cloud, making sure that they comply and are regulated and governed by that security team. Now, we're not going to stop here because the challenges continue. And models are just one piece of the AI journey that we have. Clients or agents accessing models is just one piece of the agentic AI puzzle. Traditionally, what we would have done is build custom connectors for every single API. But that traditional approach is very inefficient and cannot scale. Just imagine the number of models and imagine the number of tools that you will have, and each one started to build a bespoke API. You would never be able to move into a Gen AI journey. And I think this is where the unified protocol that was announced by Anthropic, which is called the Model Context Protocol, MCP, it provides every API producer to expose an MCP server. Now, this allows any AI agent, as you can see on the top, in the middle, any AI agent to have uniform access to tools or data, simplifying your deployment, making it consistent, and enabling rapid adoption. You don't have to worry about bespoke APIs that would have been created. There's a single infrastructure, which is MCP, that you can rely on. Now last, there's going to be a lot of agents. And as you can see that mesh that I've created on the right side of the slide, which is agent to agent. Agents are going to be developed. They're going to be homegrown by your enterprise. They're going to be external parties that will be offering agents. Or there'll be LLM models that will be actually generating agent code and creating and deleting agents by demand. And we want to build an infrastructure that can actually support all three, not just one, in a very consistent, comprehensive manner, and be able to support it in a way that is standardized. And that's exactly where Google pioneered A2A, which is agent-to-agent communication. And we've actually seen a lot of enterprises actually start to adopt, start to test, and validate what that happens. Now, as we go through it, you'll see we want to make models, agents, and tools everywhere, independent of whether you have them on-prem, in Google Cloud, or any other cloud, available to your developers, available to a common infrastructure that you can securely connect and be able to provide governance and security regulations along the way. Now, this creates a lot of challenges as we develop this strategy. So I just want to walk through what we believe are the challenges. The challenge number one, Gen AI wants to be able to leverage gRPC tools and data sources to accelerate development velocity. You've already done that for the world that's calling it traditional applications. As those applications move to Gen AI based, you want to be able to have access to the same set of tools and data sources that were available historically through gRPC. The challenge, MCP as a protocol does not support gRPC. Second, serverless Kubernetes, whether it's GKE or native Kubernetes, is going to be the platform of choice for agent developers. Today, we do not have gRPC support on serverless runtime as well as the agent SDKs. Third, there are going to be new threat vectors that are going to be introduced by Gen AI. As you can see, I continue to bring security as top of mind on everything that we do. Now, agents need to access other agents. They want to be able to access tools or even LLM models. And you want to be able to do it from anywhere in a preferred choice of your security vendor. Traditional security appliances, putting a bump in the wire or bump in the cloud, being able to redirect your traffic, that's very hard, very complex, and there's potential of that being non-optimized from a cost, performance, or even security perspective. We want to make it really simple as you integrate your security appliance of choice. And with that, that's exactly what we are doing. Three things that we are announcing. First, enabling gRPC as the native transport for A2A as well as MCP. So all those data sources and tools that I talked about, which are connecting to your traditional or today's applications, can use the same transport as they evolve to a Gen AI infrastructure or a Gen AI application. The second, security is top of mind. We had invested in this very cool technology called service extensions that provides data plane programmability. Now we are extending that in a way where you can use Google's native model armor to protect your LLMs, to protect your agents. But you can also bring third party. Could be Palo Alto AI firewall, could be NVIDIA's, or could be any other preferred choice that you might have. And finally, we also want to be able to support gRPC across all compute runtimes on Google, including Cloud Run, so that all the agent SDKs that you have developed automatically get extended and can be now made available for this new agentic world that we're going to live in. We are super excited about these innovations to come. Would love, as we bring these innovations and we start making them into preview, would love to get feedback from all of you. Try it out in your labs, your POCs, or even your pilot webs or applications that you're piloting or moving them into a Gen AI on Google Cloud. We would love to hear your feedback. I have to say, many of these things that we have made available today actually came into making thanks to a lot of the folks here in this room that actually provided us feedback as MCP was being developed, as A2A was being developed. And we invested heavily to make sure that gRPC continues to provide that continuity that you've used it in the past and now being available for the next generation of applications that are there. Now, better than me showing slides, it's good to see a demo. So with that, I'm going to announce and invite Arun, who's our Uber TL, principal engineer at Google. He, along with his team, are almost the brains behind this. So thank you, Arun.
Thanks, Muninder. Okay, so let me build on Muninder's introduction and zoom in on Agentic AI. Software as a service has had a large impact over the last 2 decades, but we are on the cusp of the next great evolution, a shift from software as a service to Agentic AI. Unlike deterministic software as a service components, agents deliver towards a high-level outcome. These agents can reason, plan, act, and think autonomously. In this new era, the API is not a backwards compatible, rigid REST spec anymore. When an agent is asked to perform an operation, like make a travel plan, it orchestrates a complex workflow by interacting with other agents and other tools, and these interactions use an AI-first natural language protocols. If microservices broke down monolithic applications, agents are breaking down monolithic AI. This is an architectural evolution. The gRPC ecosystem must evolve for gRPC to play an important role with agents like it does for microservices today. So one of the key aspects of how gRPC works with microservices is gRPC proxyless service mesh. The gRPC proxyless service mesh provides a native application integrated traffic management, discovery, security, extensibility, and observability, all without requiring sidecars. And sidecar, the operational complexity of the sidecar has been a service mesh adoption concern. To fully support Agentic AI, it is necessary to transition gRPC proxyless service mesh to a gRPC proxyless agent mesh. What does it mean? It means that gRPC as an ecosystem and gRPC service mesh as an ecosystem need to natively support AI workloads, supporting AI safety and security, like Muninder called out, adapting observability for the dynamic agent-driven protocols, integrating with the new AI protocols like A2A and MCP that Muninder talked about, to give a few examples. So this is the transition from the gRPC proxyless service mesh over to a gRPC proxyless agent mesh. So that brings us to the emerging standards for agent communications, A2A and MCP. Currently, MCP relies primarily on JSON RPC protocol with a HTTP transport. What it actually means for gRPC tool developers is that it forces them to either use proxies or to rewrite their tools, introducing friction and complexity and the lack of usability of the existing ecosystem. I know this is a topic of tremendous interest as I see a couple of presentations later on today on the exact same topic. But what if gRPC were a transport natively for A2A and MCP? All the gRPC agent service mesh benefits that we just talked about now gets integrated and directly available in your agent binary through these ADKs and MCP SDK. So now the agent application can directly support AI safety and security, agent governance policies, agent observability, all without requiring any additional operational components. The tool owners can also leverage the gRPC protobuf ecosystem like they do today with their microservices. Let's try to demonstrate these benefits by showing an example agent system running in serverless. As you all know, service mesh has historically been associated with GKE, but a quick agent development cycle, especially in some of the non-enterprise scenarios, makes serverless a very interesting platform to run agents. A gRPC agent mesh, along with gRPC support in the A2A MCP protocol, allows agents running in a serverless environment to communicate with agents running anywhere else, any cloud, any compute, tools running anywhere else, and discover them and access them with built-in AI safety and security, built-in observability, and without requiring any additional networking components. This is the promise of gRPC agent mesh. Okay, like Muninder said, time for some action with the demo. So the demo is actually going to show a gRPC as a transport option for MCP. This is not ready for release yet, but the demo is to show the progress that the team has made so far. I'll set the stage with set the stage for demo by introducing an example use case. In a typical cloud environment, a CloudOps agent needs to securely access the monitoring tools. Historically, this has required deploying a proxy between the CloudOps agent and the tool for the proxy to perform a lot of functions that we just talked about. But gRPC changes this. We are moving these functions provided by proxy directly into the agent binary by integrating gRPC as a transport for MCP and deploying gRPC agent mesh for a centralized operational control. I'm going to show a demo of gRPC support in MCP, but in the interest of time, I'm going to narrowly focus on taking TLS as an example capability provided by this integration, but you can imagine how it expands to everything else that we just talked about. Okay, so for demo, starting with the server side, we just decorate our function as an MCP tool, and the MCP SDK handles all the underlying MCP protocol complexities for the tool owner, presenting a protobuf interface to them. Now let's see the user query in action. We'll give our agent a natural language query to find underutilized VMs. The agent and LLM understands the request and calls the correct tool. The gRPC core, as part of the MCP SDK, then takes on the responsibility to provide secure TLS connection to the tool, offloading all these complexities from the agent owners. The agent binary now has all the functionalities it needs to take actions needed to call the tools. No middle box, no operational complexity. This is the promise of agentic proxyless infrastructure. Simple, secure, compliant, self-sufficient, all built on gRPC. Hope you enjoyed the demo.